All right, so let's go ahead and start off by writing down the Pythagorean Theorem. And does everyone know how to access this on the markup, where you pull this up and then there's like that pen tool you can start writing all over it? I will say don't get out of this until we're completely done with the lesson today, because it is a little bit tricky as far as getting back into the PDF to add more notes to it. And I need to figure that out more. But I'm sure some of you are better at that than me. All right. So anyways, if you're in the PDF and you're looking at this and you have the markup tool, you can start adding some stuff to it. So the first thing I want you guys to do is just write down your Pythagorean theorem, which is a squared plus b squared equals c squared. All right, so as far as this goes, and I mentioned this a minute ago, with the A, B, and C, those are the sides of a right triangle. Remember, this is only ever done with a right triangle. So I want to add a little note to that effect somewhere in the margin. So I'll do this kind of in a different color. Must be a right triangle. Now, that might sound like it's kind of restrictive because most triangles in the world are not right triangles. But it's okay because any triangle can be split into right triangles. So that's why Pythagorean theorem is still very, very useful, because you can take any triangle you want and split it that way. So just as an example, if I had a random triangle drawn here, hopefully I draw it as well as I can. All right. Let's say I have that triangle, and I am trying to figure out the area of this, and I don't have all the information I need. Well, I can split this right down here, and what I've done is I've just created a couple of right triangles. If I have enough information, I can use Pythagorean theorem to solve from there. All right, does that make sense? Yeah, so there are methods to get to that, and we're not worried about that at this moment. Okay. So we've got three sides to our triangle, A, B, and C. And what I always want you guys to do is label the shortest side A. So in this first example, I'm going to label that A. The 12 right here is the next longest side. If it gives you some side lengths, you'll know which one's longer and shorter, because sometimes it's hard to tell. So there's B. And the C is always the hypotenuse, always opposite the right angle. So I think it's helpful to do this so that you never, get confused about what should be what. So the A will always be the short, the medium for B, and the long for C. Because here's the most common problem. Is you have two values that are known, you're solving for a third. That's the situation where we would use Pythagorean theorem. You have two values that are known, and some people just plug them in random spots. It's like, well, here's, this number and this number. I'm just going to plug it in for A and B. Well, maybe it shouldn't have been set up that way. All right. So if we look at this problem, we label first. So now when we're thinking about our Pythagorean theorem, we know that A is going to be x. So that's going to be x squared. My b value is 12, so that's 12 squared. And my c value is 13, so it's 13 squared right here. Setting it up is the most, I don't want to say the hardest part, because it's not that hard. I don't want you to think it's a difficult thing, but it's where all the mistakes will happen. All right, so we can figure out what x equals. Let's go through the actual calculation process. What is 12 squared? 144. And you have calculators, so you can kind of go through that. And the x squared doesn't change, that's why I just brought that down. The 12 squared, we're going to actually evaluate that number is. We got 144. 13 squared is 169. So we're solving this just in a very straightforward way. What do we do next? Yeah, well, we want to subtract 144 from both sides. And we end up with x squared equals 25. All right, so now we've got x squared. The answer we're looking for is x. If we want to undo squaring a number, what is that? It's not divide. Square roots. And I know you're familiar with square and square root to some degree, but I just want to remind you, square root says what one number multiplied by itself will give me, in this case, 25. All right, so we've got square root of x squared. We know that x multiplied by itself is going to give us x squared, so the square root of it is just x. And the square root of 25 is 5. Now I want to point out just a technicality here. When we get the square root of a number, you technically have a positive and a negative root, because negative 5 squared is also positive 25. But for our purposes, we're always dealing with distances when it comes to Pythagorean theorem. You never have a negative distance. So we can always ignore the negative. And a lot of times you will just ignore the negative. But it's just important for you to be aware of that. Because next year in Algebra 2, you will very much be using positive and negative roots. But I'm throwing it out there now, but for your purposes, don't worry about it too much. So x equals 5. This is a nice problem because you got a whole number for your answer. All right. Now, we are going to do the next problem. Actually, before we do the next problem, what I want you to do is for problems 2, 3, and 4, the ones you see up on the screen, I want you to label your A, B, and C. Just do that much, and then we'll come back and solve the next one. All right, shouldn't take you too long to get those filled in. I wrote mine up on the screen, so if you want to make sure that yours are labeled the same, hopefully you can see my A, B, and C. I wrote it a little small, sorry about that. But A, B, and C are labeled. C is always opposite the hypotenuse, or the right angle. So it is the hypotenuse. And the A and B were split up where A is the shorter side, B is the longer leg. So the medium length side. Okay, so let's just look at the next one, and we will plug these numbers in. So tell me what my equation looks like for number 2. 3 squared plus 4 squared equals x squared. And I just have to say it again. This is where, if you're going to make a mistake, it's going to be right here. Not putting your numbers in the right spot for the equation. All right. So we can do it really quickly. 3 squared is 9. 4 squared is 16. And x squared is x squared. Now, maybe I shouldn't move too fast. Remember, 4 squared, you have a way of doing that on your calculator. You don't have to know that in your head. Any number, you have an x squared button on your calculator right here. So you can just take whatever the number is for your particular problem, do that number, hit squared, enter, and you've got the number you need. Don't try and plug all this in at the same time. Just do each step individually so that you're less likely to make a mistake. All right. So 9 plus 16 is 25. And we've already seen this. We have 25 equals x squared. What's our next operation? Square root. And x equals 5, yeah. And it's what we just did. So what we've got for the first 2 problems here are called Pythagorean triples. There are not very many Pythagorean triples, but a Pythagorean triple is whenever 3 whole numbers satisfy the Pythagorean theorem. So in the first example, 5, 12, 13, that's a very common one. A 3, 4, 5 is probably the most common Pythagorean triple you'll see. And multiples of this also work. So if I changed this to 6 and this to 8, then that would change my hypotenuse to 10. Because notice it's still just a 3, 4, 5. I just multiplied it by 2. So it works out that way also. Okay, I don't want to confuse you with that. I just want you to be aware. If you recognize some Pythagorean triples, then they are used quite a bit, and it might save you some time. Okay, so what I want you guys to do is for the next two, just practice coming up with the answer and make sure that your answer is correct. Since you have the answer key in that PDF, you can go and check yourself, but I'll put the answers up in a minute anyway. All right, so I put the answers up here again. I know you guys can see them already, but one thing I failed to do when we were answering before is you have units to this. You should include the units. So if you didn't write down the units before, you can go ahead and add that. So we have these answers, and we might look at just one more thing before the end of class. But this is really the skill you need to be comfortable with. So it's just a review day on this idea. So for the last little bit of class, let's look at problems 9 through 12, and we'll just do like one or two of them. And what we're doing here, this is not something you will typically be doing in class, but it is another application for the Pythagorean theorem. I should point out that Pythagorean triple we saw, where it was a 3, 4, 5 right triangle, that is actually one that's been very useful throughout history, and might have been used in order to check to make sure if you're building a building, a room, and you want to make sure you built this wall so it's exactly 90 degrees. Well, imagine a long time ago you didn't necessarily have a tool to do that for you. So here's what people would do. They would, let me clear this away real quick. They'd have their wall started, and if they were building it out of stone, it might have like the very first layer. And they think it's 90 degrees, but they want to make sure that it is. So what they do is they have whatever unit they're using. Let's just use feet for our purposes. Let's say they go out 4 feet. 1, 2, 3, 4. And then they'll go out 3 units from the other side. 1, 2, 3. And then they just measure this distance right here and make sure it was 5 feet. So if they had that measurement exact, they would know that they did a 3, 4, 5 triangle and it was 90 degrees. So it has been a useful triangle throughout the history. Now, of course, we don't need to do that in order to figure it out. But let's look at kind of the same idea. We want to make sure that this is a right triangle. We want to make sure we actually have a 90-degree angle. And so let's just look at the first one. We've got 9, 12, and 15. And some of you might be able to tell right now if this is right triangle or not. But I'm going to label, first of all, the shortest side, and it tells me the side length. So I know this is the shortest. That's the medium. That's the longest. So if this is a right triangle, I'm going to put this in dashes. This should be a right angle right there. And I'm checking to make sure that it is. So all we have to do is plug these numbers in. A squared, so 9 squared plus 12 squared equals 15 squared. And I'm just going to do this one pretty quickly. 9 squared is what? 81. 12 squared is 144. And 15 squared, does anyone know that? Is 225. Now let's add up 81 and 144. What do we get? 225. So 225 equals 225. That means when these are equal, this is a Pythagorean, or this is a right triangle. Because a squared plus b squared will equal c squared only when it's a right triangle. If it wasn't, this wouldn't turn out to be true. So if we look at these others, and we don't need to dwell on this too long, because you're not going to be doing stuff like this moving forward, but it is another application of the Pythagorean theorem. Here's a triangle. It looks like a right triangle. Is it really? If it's not exact, then it's not exactly 90 degrees. It might be 89.8. But if it's not exactly 90 degrees, you won't get this to work out perfectly. All right, so just get some practice with this today. You have your answer key in that PDF. And moving forward, it's going to be kind of expected that you know how to use Pythagorean theorem. So let me know if you have some confusion on that today.